So, hello there. Let's just be once again. Be sure you can hear me, yes? With the group chat. Let's check here. So, um, can you hear me? Testing. Um, so today's mostly a review lesson, but well, let's get to it then. So, welcome. Today is Let's Code Java, day 5 of the lesson. Here's the table of contents. So what we'll be doing first is that we'll review how the is that we'll just do some basic review. Then afterwards, we'll get to go into some distance sensing. Then afterwards, we'll go and learn about autonomous navigation. So here's some review. So for movement, first you have to set the power from 0 to 1. Technically, it can range from -1 to 1, but let's not get too technical here. Then afterwards, you sleep some time in order to allow the motor to run along and roll and spin. And this is measured in milliseconds. And then afterwards, you then stop the motors by setting their power to 0, which means no more power is going to the motors anymore. So let's say stop. So here's our first challenge for the day. Open up the virtual robot simulator link. Copy and paste the code in this link, and try to have your row move forward and make a triangle like the one you see on the screen. When you manage to do that, please tell me in the chat. By the way, your triangle doesn't need to be exactly like the one in the code. It doesn't need to be exactly like one in the GIF. All it has to do is roughly resemble it. Frank. Again, we are done. Please tell me in the chat so that I may know when to move on. They're not already. I shared the link above, but I'm sure then let me go reshare the link. No, the link's reshared. Again, open the virtual robot simulator link. Select on about Java, copy and paste the code as always, and make a move in the triangle. Well, for the sake of time constraints, let me move on to telemetry. So, in order to review telemetry, also, when you define a variable in Java, you have to set its type. These variables are the whole numbers, which is a whole. So it will be an integer type. The other common variable types are strings, which text and variables, and floats, which are decimal numbers. Now, there are many more variable types, but these are just the common ones. So, define a variable A to be B, set its value 20. Define a variable C, set its value to 10. To display the telemetry data, all you have to use is the telemetry.add data command with the name you want to display next to your variable screen. Finally, update your telemetry screen to show your data telemetry.update is used. So here's a telemetry movement challenge. Go to your previous code. Have the robot display the runtime and what side of the triangle is currently moving on using the telemetry, and to make an integer variable to store which side of the triangle the robot is on, and add it as the robot is moved from one side to the next. Now, for those of you who have recently joined, okay, this builds off the previous challenge where you are supposed to go and use this robot, where you're supposed to go to the robot simulator link. You're going to go and copy and paste this code, and then afterwards, you're basically gonna go and make the robot try and move in a bit of a triangle shape, like the one shown in this slide. Like here, see, it goes forward, turns a bit right, goes forward a bit, turns right again, goes forward a bit, turns right again, and then it goes back in the triangle shape. You go you go over telemetry, and then afterwards, this is to kind of just be sure that when it does do that, you can report the run times and size. By the way, for any of you who have recently joined, you're not missing out much. So this is mainly since we're currently in the review stages of the lesson. But after we finish reviewing, though, we will learn something true. We will learn some new things, though. You'll even get to have some insight into how what real code we use in the team. More practical stuff after you learn this tutorial. Bit of a treat. So again, when you're done, be sure to tell me. So again, when you're done, be sure to tell me. Nope. But there are always check marks. That's strange. Hmm. Hmm. That's certainly strange. There are always check marks here. Hmm. Hmm. Alrighty. Um, there shouldn't be any need for you to import telemetry. Should come pre-installed the code. Let me go check. Um, go and see here. Yeah, there shouldn't be any need for you to import telemetry. So, anyways, for the sake of timing, I'll just continue on with the lesson. So, reiterate. So, there's a for loop. Basically, first you have to define it in the format. There's a variable here, which in this case is I, which is 0. Iterates until it reaches the condition. So as long as I is below 5, then it continues to go and do this code. And then after it's done, and then it follows this final statement, which is incrementing the variable. This is useful for repeating a set of commands for a set amount of times. So here's a challenge with for loops. You can go to your previous code, use a for loop to simplify the repetitive code. So instead of having your robot turn into a triangle 3 times over, you can just use a for loop for it. You can use the variable used to increment the for loop in the telemetry to display the side of the triangle you want to use the robot on. So again, when you're using this, the integer I is equal to 1. This integer that you define can actually be used in the body of the code as well. So you can use for integer I is equal to 1, I is below or equal to 3, and I plus plus as a hint to go and repeat your code 3 times. And then afterwards, of course, you should probably stop the motor movement and in the body of the code, again, make it move 3 times and also maybe record it in the telemetry. If you want to figure out how you can display variables in telemetry, then you can do telemetry.app.data runtime, which is the description of it, or whatever you want to name it. And then afterwards, get runtime. Instead of using one of these things, you can instead just use I, which represents the variable that you already set in the loop. So I'll give you some time to work on that. Again, I'm sorry that this is a bit boring for all of you. Uh, this is mainly just review, but there are going to be more. Why is there drawings here? Oh, this is an annotation. Oh, huh. Oh, you can annotate this. Huh. It's a fun little feature. Well, anyways, I'll give you some time. Again, there's more exciting things that will occur, but for now, we'll just if you'd like me to slow down, you be sure to tell me in the chat. But I guess I'll just continue on doing this passively for now. Oh, great then. So I suppose I'll just move on. So there's a while loop. So while the condition you put in the while loop is true, it'll just repeat the code. That's all it does. So again, go to your previous. So here's a new one. Okay, go to your new code. Challenge you to switch out the for loop for a while loop, and then afterwards, here's a hint. You can convert a for loop to a while loop relatively easily, where you just initialize the variable, set the variable so that while is below or equal to 3, display the side of the triangle based on I, turn around, make the side of the triangle, increase the value of it by 1. This way, since you've initialized the variable to be 0, as long as it will continue to iterate 3 times until I is equal to 3, in which case it will then stop. So I'll let you go do that real quick as well. Again, please do try to text me. Please do try and tell me in the chat if you've done something or not, because well, it really helps you know if I'm going too fast, if I'm going too slow, or if I'm doing fine. So yeah. Again, if you have any questions, don't be afraid to ask me. I'm always here to help. Oh, great then. Well, so for any of you who might be stuck, here's the code to the solutions so you can keep up. Well, not not to keep up, but That's probably not the best way of wording it, but well, this is just to see if your code is currently see what works, if your code's different, if you have any troubles, or if you just need some catching up to do to go if you've recently joined, then yeah, use the link. Perhaps my previous wording is not the best way to put it. So then after there's color sensing. The tutorial for color sensing is basically first you have to import the color sensor, then afterwards you have to set up with the variable private color sensor, bottom color sensor. Then afterwards you hardware map it to the color sensor you want. And then afterwards, you then set up integer R to you set up various variables that can represent the variables 3 colors that the color sensor can detect: red, green, and blue, because this is the color that every single color you can see on a computer is composed out of. Then afterwards, while blue is below 2000, basically, or this will basically mean that while the color sensor basically is not showing extreme blue, they'll just add the data. And then of course, if it is over 2000, it'll stop. So yeah, this is just to give you an example of how you can use color sensing. So hopefully it works this time, since I remember last time it didn't bode too well. So you can go to your previous code, add a color sensor to your robot, and have your robot turn around after finishing making a triangle. Then have your robot move until it sees the red line on one of the right squares, like the example on the right. So as you can see, it goes forward, turns right, goes forward, turns right again, goes forward. Then afterwards, turns right again, goes into a forward, and then at the end of that, it then turns around and then continues to go forward. Give it some time. Until it manages to detect the red square. So, I'll let you do that. Again, any of you who have recently joined, just use the link posted in the chat. And hopefully you can get done with this challenge. Oh, great. So again, for any of you who recently joined, in the chat, well, I should probably repost it since you just recently joined. So currently we've just been doing some review stuff for right now. So if you've been paying attention to class, don't worry, it's not like you're missing out very much. So we're just reviewing color sensing for now. So previously what people have been doing is that they've been making a robot, they go forward, it goes in a small triangle. Then afterwards, the twist that we're adding now for color sensing is that after you made the small triangle, as you can see here, you then turn around and then you go forward until you eventually detect the red of this red square, and then you stop. So yeah, when you manage to complete that, please go and tell us. Please go tell me. And oh yeah, also I suppose you probably need the virtual robot simulator, don't you? So here's the link to the virtual robot simulator. Yep. I'll go and give you some time to complete it. Just most of this is review, but when you do manage to complete it, please do tell me in the chat. It really helps me know if I'm going too fast or too slow, or if I'm going just right. Timing a bit bad. So, let's take a pacing. I'll just move on. So, here's more things about motors. Here's the ring shooter and flywheel. As you know, you have to set up the hardware class again. Ring shooter is hardware map that to the ring shooter, and flywheel ring part that to the flywheel. And then afterwards, when you shoot it, you just simply set their power, take over, rest, set their power again, and rest again. So then afterwards goes your previous code, add the flywheel and then shoot your motors. At the end, your robot should turn and shoot the rings into the goal. So really taking a lot longer than I thought it would. But just to be warned, this is the last part, okay? Just endure it for a bit longer. This is the last part before we get on to actually some of the new information you get to learn, which is really cool, I think. Since I'm sure you're probably a bit tired of all this review, I'll just move on after a shorter period of time. Move on after a couple minutes. Alrighty, so I'm sure you're all tired of some review. So let's go to actually some of the new fun things. I'm sorry this may take a bit long, but this is the last meeting after all. So here is distance sensing. So delete all your code and copy and paste the code from this document. Oh god, this is a long link. I'll give you some time to analyze the code to see if you can figure out how it works. Bottom color sensor. Why does it get distance on a color sensor? No. The program is stopped. Really? Let me take a look into it. Really? Hmm. Hmm. Well, I suppose it doesn't matter too much. Alright, so unfortunately, I'm not entirely sure if it actually works or not since well, I'm not on my computer's acting but slow, but there's very well a possibility that it may not actually work that well. So, okay, so let me just give you an explanation how distance sensing works. So first of all, you import the color sensor library like in normal, and then afterwards you import the distance unit library. Then afterwards, use the usual hardware map method to add your color sensor. Again, bottom color sensor equals to hardware map color sensor to bottom color sensor. Then use the distance function to specify your unit to measure the distance to the ground. So, the reason why it probably doesn't matter too much is that there's no challenge for this for a pretty obvious reason, is that the distance color sensor is pretty useless because it really can, it measures your distance from the ground. There's a constant distance from the ground. It's not really like a useful function at all. Previously, this color sensor was used on Claude and was used to detect during the autonomous period when the robot had a white sphere or a yellow square, and how close they were. Both the color to determine the shape and the distance mattered, so the color sensor helped a lot there. But unfortunately, in this current scenario, where it is currently attached, it is not the most useful position. Like here's something a bit more interesting though, perhaps. This is autonomous navigation. This is how you can use odometry. So, first of all, what is odometry? Well, odometry is the use of sensors to determine the robot's position. It uses a dead wheel, which is an unpowered omni wheel. It has the rotary encoders to track distance travel. Odometry allows for localization autonomously tracking the positions of the robot, essential for for advanced autos. A three-data-wheel odometry localization system is installed in the holomatic drivetrain. So as you can see here, so in order to answer some potential problems, some potential concepts you may have. Basically, conceptually how an odometry works is that in order to get somewhere, your wheels, as you can see here, must spin some amount of times in order for you to get from somewhere to somewhere. So basically, these types of wheels are just used to go and track what these larger wheels do. Now, the reason why you don't track the movement of these larger wheels and why you have to install these types of odometry dead wheels is because these types of wheels are not built for you to be able to measure out distance very well. So you have to use these types of odometry wheels. And the reason why they're omni wheels is because in omni wheels, you see how they have this checkerboard pattern? Well, the black bits on the checkerboard, I think you can see a bit clearly here, they're actually spheres. And as a result, they allow the wheel to spin normally forward and back. But if need be, they can spin side to side without any resistance. So this is especially useful since they use these types of helical drive wheels, which again have the cool feature of letting the robot drift left and right. So this is these omni wheels allow. So by using a combination of these omni wheels, it allows you to detect if it's going forward or how much is turning by, because of course this is the left side, this is the right side, and how much is drifting, which is the third wheel's purpose. So here are the benefits is that so here's the drive wheel benefits and drive wheel odometry. So this is what I'm going into where this is what happens when you don't use odometry, when you don't use these types of omni wheels. You can just use these regular motors. So as I've said, there are no dead wheels needed, but there are pretty big negatives, which is basically mechanism wheels experience slip as the robot moves, and relying on their motor and curve decreases position accuracy, which is basically a holomatic. This is what it looks like with no dead wheels. The drivetrain will use the driver encoders for autonomous navigation. Again, basically, you can use these types of wheels for odometry, but just again, they're not the most accurate method to use in the world. It could work for your team, depending on some lower precision level circumstance, but for the purposes of autonomous, where your robot will be repeating a set of actions and be moving around a lot, assuming you create good autonomous, even minor slips in the robot, even minor inconsistencies can really mess up your robot over a long period of time. Like I'll give you one example. During last year, for many of the robots, if they slipped or if they just or if they bumped into another robot, even slightly, the storing system used during the autonomous period requires you to put a cone on a pole. Even if there's a little bit of slip, unless if you code using what I will then describe later in order to go and counteract this problem. But for most robots, if you rely solely on just without adjusting your path, because our team uses Roadrunner, so if it does get knocked slightly off track, it can readjust somewhat effectively. It's not the best in the world, but at least it's better than nothing. But for most robots, you can imagine that as they have to go through, like, say, a track of some arbitrary sort, even if they get knocked slightly off course, when they go back to repeat it, they'll become increasingly more and more off their original path. So this will cause increasingly larger and larger issues. So this is the reason why you should use odometry, and why, generally speaking, you shouldn't use drive wheel odometry, since it's just not as accurate or not as good. Again, though, hypothetically, though, you could use this. There's another option. So then there's also two-wheel odometry. So the two benefits of this one instead of the previous three-wheel odometry is that this only needs obviously two dead wheels, and there's no worry, and you don't need to worry about mechanism wheels slipping. The downside is that you need an internal motion unit to determine orientation. The IMU communicates through the I2C, which is very slow, and will significantly delay loops, reducing accuracy. So a holomatic drivetrain with two dead wheels. So basically, this is center of rotation. This is the X and Y, and then it relies on this IMU. I think it's like let me see, what does IMU stand for? I forget. Maybe it's internal mass unit. Let's see here. Inertial measurement unit, my bad. It's an inertial measurement unit, which basically lets you determine how much the robot's turning. So, unlike with this three-wheel odometry, as you can see here, we're basically your left and right are calculated by how much this left wheel spins and this right wheel spins, or to calculate how much your robot's turning by. Instead, this works by basically getting your X and Y direction from some point, and then afterwards, and then it detects how much you rotated the robot by in order to calculate it. Again, you can also use this method. It works, but it's slower since the IMU obviously needs to do its job, which is not as quick as just simply getting getting the wheel directions. So this will delay your loops, which will reduce its accuracy and also reduce the time the robot can physically spend moving around and doing all the scoring things it needs to do. And then afterwards, this is generally the best option, and this is more or less a standard option, is to use a three-dead wheel odometry. The benefits of this one is that it's the most accurate position tracking system, most accurate it can be. Downside is that the three odometry wheels take up a lot of space on the drivetrain. So if you're trying to go for a small robot or if you're trying to go for a lightweight robot, it perhaps is not the best option for you. So, okay, let's go over a review. There are three types of odometry. First of all is that there are only motor encoders, which are just using the encoders built into the motor, which basically tell you how much the motor is spun by. This is the least accurate, but it also requires the least amount of parts. Second one is that this is two dead wheels, the two omni wheels here. This is a bit between the motor encoders and three dead wheels. It's not actually it's the second least accurate. It makes it sound worse than it is. It's not the most accurate, but it's still fairly accurate. And it has less parts than three dead wheel, which has three wheels, and this only has two wheels. The three dead wheels is that it has the most accurate, but also takes up the most space. So you have to balance these trade-offs when you're building a robot. Do you want to go and have a high-level precision in a big, bulky robot? Or do you perhaps want to go for like a lighter weight robot that's quite agile? Because obviously you can't have a lot of mass, and you can't have a lot of mass while having a lot of speed necessarily. There are weight limitations on that to prevent that from happening. So when building your robot, you have to take in mind all these considerations. So how do you make odometry work in your code? This is probably what you want to learn. So for pure pursuit purposes, you calculate the robot velocity to reach a point from a current position. So take a little example of this line. Say the robot needs to move in this direction roughly, just this ziggly line. Well, we enter in the waypoints to create a line and path for the robot to follow. This is the line that's following. Place a circle around the robot, see where it intersects with the path, and have the robot orientate itself towards the intersection. So again, circle, and here's the intersection, and this is where it intersects. So the robot should point towards this intersection, and then afterwards it should adjust its velocity accordingly to follow this path. This pure pursuit method is how you go and allow your robot to stay back on track in the event, which is quite likely, that it gets knocked during the autonomous period. Without this type of pure pursuit mechanism, which is the reason why you implement odometry, is that if your robot, say, gets knocked off this path, okay, or say your motor is say you're slightly off with your math and your motors, they don't quite line up, even if you have something as simple as a robot going in a straight line, if you don't turn around and go back and forth and you're turning just slightly off, well, then the robot can increasingly move this way, goes straight down, maybe it moves all the way here, but slightly off, goes here, slightly off. And then after you repeat it a lot of times, which you normally do during autonomous, it may completely veer off the map. So this is the first method you can use. So here are the waypoints, 0, 0, 3, -5, 0, 2, 2, 3. The reason waypoints are basically the edges of the line, per se. So then afterwards, these are the path. This is the path generated by the waypoints. Basically, these are the points you want the robot to move towards. So then generates a path to the short straight lines. This is the shortest one to go towards the path. Then afterwards, you then draw a circle around the robot to determine its intersection. And then afterwards, when the circle intersects with the line, it will then go towards that intersection. So you can get started with pure pursuit over here. Now, I'm aware this is a bit less of a demo so far than what we're currently used to, but yeah. So currently, is it making sense to you all? I want to be sure. Is it making sense to you? If you have any questions, just put them in the chat. No? All right, then. So then afterwards, here's rotor. Again, feel free at any time to ask any questions in the chat. Okay, I am here to answer your questions and help you. But we're going a bit over time as is, so we're almost done, so don't worry about it. So here's the Roadrunner. Give the coordination and the orientation if wanted. The Roadrunner will generate the most efficient path for you to follow these points, and afterwards it'll often create a spline path which the robot's spinning while it moves in order to maximize its efficiency. So here's a visual representation of how it looks. So say you want the robot to move in a straight path, and then say you want it to turn this way. Well, there are two ways to accomplish this. The first way is that you can program it so that the robot goes forward, turns around, and then afterwards goes forward. This may be the most obvious path, but it would be much quicker though if the robot instead simply started moving forward while it was turning. This is the point of Roadrunner, is that it will allow you to go in and create the shortest path possible for your robot to allow for the most efficient movement. This is very, very useful for when you really when you're really cutting the time and you really want to go and make your robot perform higher than it is. But for programs like Roadrunner, as you can imagine, using this complex moving pattern requires you to use some higher level odometry than perhaps higher level odometry in order to have a high enough level of precision to be able to maintain this overly precise path. And afterwards, here are the instructions to get started with Roadrunner. So, anyways, I'm glad all of you have managed to sit through this 5-course lesson here. This is the end. If you have any questions you would like to ask me, tell me just at this moment, or else you're free to leave. Again, I understand the information you learn right now may not be immediately applicable to your regular lives. But hopefully, though, that this short little tutorial will go and help you, and maybe perhaps if you choose to join FTC or FRC or any of those other coding challenges, or if you decide to just simply take the Java knowledge and use it in using your school, use it in your job. Hopefully, though, the lessons taught here can be carried out throughout your life and will prove useful to you. If you have any questions, then I understand some of these topics may be a little hard to comprehend. Be sure to go and put in the chat. Otherwise, thank you for being a part of this lesson. Thank you for being part of this 5-lesson experience with me and putting up with my words. And enjoy the rest of your day. Yes. Goodbye. So since there doesn't seem to be much questions left, well, bye then. Enjoy the rest of your day, and well, enjoy this currently